we are going to be simplifying rational expressions. We've actually been doing this for a while. We might have had something like 10 over 6 before. This is a rational number, but we're going to use the same principles in simplifying rational expressions. So I can actually factor this and write it as 2 times 5 all over 2 times 3. And one fact of life, 2 over 2, anything over itself turns into 1. So we say that it cancels. Now we've been doing this for a while. That's how you reduce a fraction. Now you're going to apply the same sort of thing to something a little more ugly. Say you had this. Okay. So when you multiply, you're going to be just multiplying across here. And once you multiply across, then you're going to do what we did up here. You're going to simplify factors that are the same on top and on bottom. So what we'll have here is 6x to the 10th, that's the top being multiplied across, and then we'll have 144x to the 4th on the bottom. And now I'm going to think, if I have 10x's on top, 4 on the bottom, 4 of them are going to cancel. So I know that for the x's, there will be 6, and it will be left on top. Now the 6 out of 44, I have to break that down. I know that both 6 and 144, 2 goes into them. So that will simplify to 3 over 72. And I happen to know 3 goes into 3 and 72. So this is going to turn into 1 and 24 if I do the division. So since there's a 1 on top of 24 on bottom, I can just write it as x to the 6 over 24. But let's say that we wanted to do this problem again. But we wanted to simplify beforehand. There's something called cross-simplification. Before you multiply, you can actually simplify diagonally. So actually, I could simplify the 6 over 12, I cross them out, and I divide by 6 on both of them. And the same goes for these x's. This would turn into just 1x, and this would cancel. This would turn into just 5x's, and this would cancel. And then we have 2 times 12 on the bottom. So it's kind of a mess, but on top we have x times x to the 5th, which is x to the 6th, and underneath we have 24. Same answer. It just might be a little easier because the numbers don't get as large. Next, you're going to see things like this. You're going to have a rational expression with a quadratic or something even bigger on top and on bottom. The first thing you need to do to simplify this is to factor. Kind of like how when we had 10 over 6, we factored those numbers. So this is going to be x minus 4, x plus 2 on top. Underneath it's the difference of squares, so it's x minus 4, x plus 4. And when you have things the same on top and on bottom, those can cancel. This right here is your fully simplified answer. Now if you've already done some graphing rational expressions like we have, then you know that this actually here, it represents a whole, but we're looking at it from a different standpoint. We just want to simplify these expressions. So here's a try problem. Try doing x squared minus 9 all over x squared minus x minus 6. Okay, so to solve this, right away I am factoring. On the bottom here we have x minus 3, x plus 2. The things that will cancel are x minus 3, so our final answer is x plus 3 all over x plus 2. Now it gets a little more complicated. For example here, we are now multiplying them together, and we're going to make use of the idea that before we multiply all together across, we're going to cross out things and simplify before. So first, let's start factoring. Like right here, you might think that we can't factor this, but remember GCF. We can pull an x out. It's going to be x and x minus 1. The bottom here is going to be the difference of squares again. On this other one, what goes into negative 32 and adds up to negative 4? That would be x minus 8. and x plus 4. And then down here we still have our x minus 1. Okay, now we can look. If there's anything on top and on bottom, we can cancel, like x plus 4 and x plus 4, x minus 1 and x minus 1. And there's nothing more, so we just write what we have left on top and on bottom. And since it's multiplying, it's just going to be, you're just going to put them next to each other. Now, some books will have you actually expand it out again and write it like this, but I think either of these answers are just fine. And our last example here, we have a complex fraction. We're actually taking the top fraction and dividing by the bottom fraction. So, to do this, dividing by fraction is actually multiplying by the reciprocal. So I'm going to rewrite it first. I keep the top, I take the bottom, and multiply by the reciprocal. I flip it upside down. Whenever you see division, this is what you should do. Alright, next step. Now I'm going to factor to see if anything can cancel out. Whoops. I say factor and then I just rewrite it. What goes into 1 and adds to 2? 1 and 1. Underneath we have x minus 3 still. The other side, it's going to be a difference of squares. And down here we have x plus 3 and x plus 1. We're going to have a lot of things cancel out here. We'll have minus 3 and minus 3, plus 3 and plus 3, plus 1 and plus 1. We are left with just x plus 1 on top. So that whole ugly expression has simplified down to this nice little binomial.